For problem 2, we want to write a polynomial function that has zeros at 4, 0, and negative 2. Well, since it's a function, it should look like f of x or g of x, but it should have a name. And since we have 3 zeros, we're going to turn each of those zeros into its factor. If 4 is a 0, then x minus 4 is a factor. If 0 is a 0, then x minus 0 is a factor. And if negative 1 is a 0, then x minus negative 1 is a factor. Now it's just down to multiplying these three things out. What I notice first, of course, is this x minus 0. I'm going to just call that x, and I'm going to leave it out in front. And first, multiply the x minus 4 times the x plus 1. Foiling those two, we'll end up with x squared minus 3x minus 4. Now, distribute the x to get x to the third minus 3x squared minus 4x. And that will be our function f of x equals x cubed minus 3x squared minus 4x. Writing a polynomial function with complex roots, we're going to do the same thing. We can come up with a function name. This time I'll call it g of x for no particular reason. And since 7i is a 0, that means x minus 7i is a factor. And if negative 7i is a 0, then x minus negative 7i would be a factor. Now we just need to FOIL these. First will give us x squared. Then x times 7i is plus 7ix. And then minus 7i times x is minus 7ix. And then lastly, negative 7i times positive 7i is negative 49i squared. The nice thing about complex zeros is that they always happen in these conjugate pairs, where one of them is a positive 7i and the other one's a negative 7i. What's super sweet about that is that when we do this foiling, in the middle we'll have that plus 7ix and minus 7ix, and these two will cancel each other out. The other thing is this I squared. See, I is equal to the square root of negative 1. So if we're looking at I squared, that'd be the square root of negative 1 squared, which we call negative 1. So when we're simplifying this entire expression, we'll have x squared minus 49 times negative 1, which is x squared plus 49. Then label it with the g of x, and there is our polynomial function, x squared plus 49. As the complex zeros get more complicated, they're still going to work in the same way, and they're still going to happen in these conjugate pairs. See how this one says 2 plus 9i and 2 minus 9i? The complex part, the part with the I in it, those are opposites, plus 9i, minus 9i. That's what makes them conjugates. So when we're setting up our polynomial function, we give it a name. This time I'll call this one h of x. And if 2 plus 9i is a 0, then x minus 2 plus 9i is a factor. And if 2 minus 9i is a 0, then x minus 2 minus 9i is a factor. And now we need to multiply these things out. Now there are a couple of little tricks that will help us along the way. The first thing that we do have to do is distribute that negative, that minus that's inside each of these factors. So distributing the negative to the minus here, we'll have x minus 2 minus 9i. And in the other factor, it will be x minus 2 plus 9i. Now, the nice trick that we can do is reinsert a pair of square brackets, but this time put them around the x minus 2, because each of these factors have an x minus 2 in it. Then we'll have the difference of two squares, something minus 9i and something plus 9i, where those two somethings are the same. So if we're going to FOIL this out, what we'll do is take that x minus 2 times x minus 2. Those are my two firsts. And that will give me x minus 2 squared. Then doing the outsides, we'll have plus 9i times x minus 2. The insides will give us minus 9i times x minus 2. And doing the last, minus 9i times plus 9i, will give us negative 81i squared. And again, because they were conjugates of each other, we see we have this positive and negative happening where these two are going to cancel each other out. So we just have to clean up what we have left. First of all, this x minus 2 squared, we have to FOIL that out as well. And when we get to the last term, the I squared again is negative 1. So x minus 2 times x minus 2 is going to be x squared minus 4x plus 4. And then this last term will be plus 81. So our entire function h of x is going to be x squared minus 4x plus 85.